Welcome to aminacademy.com. In mathematics, let us discuss about Fourier series. Some introduction and periodic function we'll discuss. Most of the engineering phenomena that are studied in engineering and science are periodic in nature. For instance, current and voltage in an alternating current circuit. These periodic functions could be analyzed into their constituent components, that is fundamental and harmonics. It can be done by using a process called Fourier analysis. What is Fourier series? A Fourier series can be defined as a way of representing periodic function, possibly infinite, as a sum of sine and cos functions. The Fourier series is known to be a very powerful tool in connection with various problems involving partial differential equation. The graph of periodic function f of x that has a period equal to L exhibits the same pattern for every L unit along the x-axis, so that f of x plus L is equal to f of x. That means every interval of L, it changes to the same position. Means same function for each value of x. If we know that the function looks like over one complete period, therefore we can sketch a graph of the function over a wider interval of x that may contain many periods. Here, look at these figures. This is a triangular view, semicircular view. It's a square wave, sawtooth wave, triangular wave, semicircular wave. After some intervals, it comes to same position on an x-axis. We can use this property of repetition that defines a fundamental spatial frequency k equal to 2 pi L to give a first approximation to the period pattern f of x. Then we can say function f of x c1 sine of kx plus a1 equals to a1 cos kx plus b1 sine kx, where symbol with scripts equal to 1 are constants that determine the amplitude and phase of this first approximation. A much better approximation of the periodic pattern, that is function f of x, can be built up by adding an appropriate combination of harmonics to the fundamental sine wave pattern. For example, adding c2 sine of 2kx plus c2 equal a2 cos of 2kx plus b2 sine of 2kx, which is the second harmonic, and c3 sine 3kx plus a3 equal a3 cos 3kx plus b3 sine 3kx, that is the third harmonic. Here, symbols with subscripts are the constant that generally determine the amplitude and phase of each harmonic contribution. We can even approximate a square wave pattern with a suitable sum that involves a fundamental sine wave and a combination of harmonic of this fundamental frequency. This sum is known as the Fourier series. Now, what is periodic function? A time interval between two waves is known as a period, whereas a function that repeats its value at regular intervals or periods is known as a periodic function. In other words, a periodic function is a function that repeats its value after every particular interval. Look at this figure. Here, this is a sine wave. Here, this for a particular point in one position to next repetition position is here. The distance between these 2 points is called a one period. Here, another period. It's repeating. A function f is said to be harmonic if for some non-zero constant p, it is the case that for all values of x in the domain. A non-zero constant p for which this is the case is called period of the function. If there exists at least a least positive constant p. With this property, it is called the fundamental period, also primitive period, basic period, or prime period. Often, the period of the function is used to mean its fundamental period. A function with period p will repeat on interval of the length p, and this interval are sometimes are referred to as period of the function. Now, further, we will discuss about periodic function. If at equal intervals of abscissa x, the value of each ordinate f of x repeats itself, then f of x is called a periodic function. A function f of x is said to be a periodic function if there exists a real number a such that f of x plus a is equal f of x for all x. For all x. The number a is called the period, where a is now, therefore you can write in general f of x equal f of x plus a equal f of x plus 2a equal f of x plus 3a, which is equal in general you can write f of x plus na. Now for example, look at this example. Sin x equal sin of x plus 2p equal sin of x plus 4p. For even number multiplication of p, it's repeat. Then generally you can write which is equal sin of x plus 2np. Even multiplication of p, which is for next example cos of x is equal same way cos of x plus 2p equal cos of x plus 4p, then which is written as cos of x plus 2np. Here cos x is periodic function. Here sin and a cos x is a periodic function of the period 2p, where period equal to 2p. Here sin x and cos x is the periodic function. Now these two period functions we can define a Fourier series. Now is that is generally you can write f of x is a0 by 2 plus a to n equal to 1 to infinity an cos of npx over L plus a n equal to 1 to infinity bn sine of npx by L. npx by L is called a Fourier series of f of x with period 2L. Is called a Fourier series of f of x with period 2L. And a0, a n, bn are given the formula called, these are a constant, or these are constants. Now in future videos we'll discuss further about Fourier series and examples. We have done. Please subscribe our YouTube channel.